Hello, welcome. Today we are here to discuss a searching technique which is binary search. A straightforward question in lead code. We'll see what are the pointers that we use, how to stop, whatever we do, how exactly binary search works internally. So the question is straightforward, guys. Given an array of numbers which is sorted in ascending order, so the array is already sorted in ascending order, and we need to write a function to search target in the nums. If target is there, then return index, otherwise it will return -1. So we are searching for an element we need to use a binary search logic. This is a question from lead code, which is question number 704. So let's see this one, guys. Very simple one. So let's take an example. Let's search, let's see how exactly this works and all. So let me take one example, which is a sorted array. So 8, 11, 13, 15. Next, 8, 11, 13, 15, 19, and 20. This is your sorted array. This is your sorted array. So as you guys know, this array is already sorted. Let me note down the indexes 0, 1, 2, 3, 4, and 4 and 5. 4 and 5. Let's say our target t equals to, let's say I'm searching for something called as 19. I'm searching for something called as 19. Now what all variables we'll take? So we'll take left, left L equal to zeroth index, and right equal to, we'll take fifth index, which is last index of the array. Basically, the main intuition or main idea behind using this particular two pointers is to identify the range of my array where I need to search. Initially, I need to search in the entire array. So that's why initially left is pointed to 0, and right is pointed to 5, left is pointed to 0. So entire binary search algorithm works on dividing into halves, dividing your array into halves. Every time it will divide into two halves, guys. Every time it will divide it into two halves. So how it will divide? So it will calculate a mid value. How you will calculate a mid value? L plus R by 2. L plus R by 2. L plus R by 2. So this will help you to find out a mid value, and from that mid value you will find out and divide the array. So let's calculate a mid value here. What will be the mid value? 5 by 2. 5 by 2. So which will be 2.5. That the whole number will take is 2, guys. We'll take it as 2. So I'll go to second index. I'll go to second index. Now the main thing is I'll see whether my target is here. What is the target? 19. What is my index value? 13. Are they same? No, they are not same. 19 and 13. 19 and 13 are not same. 19 and 13 are not same. Okay. Till here, I think everything is clear, right? Now our actual thing comes. So I have landed in the middle element. Now I checked or I compared with the target. They are not matching. Now I need to decide on which side I need to search for. I need to decide where I can search. Obviously, if you see 19, you need to search on the right side. Why I need to search on the right side? Because value 19, value 19 is greater than 13. 19 is greater than 13, which means as the array is already sorted, array is already sorted, the elements which are greater than will be right to the 13, so that is the reason we'll simply search in the right half. Right half. We will not even worry about left half, because these values are less than 13, which means that 13 itself is not my answer. So the remaining values will also be not my answer. I need to search on the right side. Okay. Now How to search on the right side? Same way. Now left pointer will be updated to mid plus one. Mid plus one. Left pointer will be updated to mid plus one. Why not mid? Why not mid? Because this index we already compared. That is not matching. So that's why mid plus one. Mid plus one. Now let's say what will be updated value of mid? Updated value of mid. 3 plus 5 by 2. 3 plus 5 by 2, 4. 3 plus 5 by 2, 4. What is the value at index 4? 19. What is the value at index 4? 19. Are they same? Yes. So return the index. What is the index? 4. So return index 4. Return index 4. Okay. I hope this particular thing is clear, guys. I hope this thing is clear. Yes or not? So whenever the value is there, we'll go to that value and we'll return that index. We'll return that index. So this is how entire binary search works. So we will be repeating this process while your left is less than or equal to r. What is the process? What is the process? First thing, calculate the mid. This is your first thing. Calculate the mid value. Okay. What is the second thing? What is the second thing? Compare with the target. Compare with the target. Let me note down the steps. Let me note down the steps for you people. What is the first thing? Calculate mid. Calculate mid. Next thing is compare target with mid index value. Mid index value. Whatever the mid value is there, whatever the index value is there, from that index we need to get the value and we need to there. After that, okay, if if they are matching, return mid. Return mid because that is your answer. If they are matching, return mid. Okay. If they are not matching, if middle index or mid index value is greater than target, if it is greater than target, search on left side. Search on left side. Else search on right side. Else search on right side. Else search on right side. You can ask, see, why I'm doing else? Why I'm doing else? Because if it is not there in the middle, if it is not there in the right side, okay, sorry. If it is not there in the middle, if it is not there on the left side, obviously where it will be? Right side. So there is no point of checking the condition. Checking the condition. That's all, guys. This is what your entire binary search is. Let's execute this one and let's see. Int left equal to 0, right equal to nums dot length minus 1 and int m equals to, let's say, 0. Now, how many times I need to repeat this process while left is less than or equal to r? What is the process? First thing, calculate the mid value, L plus r by 2. L plus r by 2. After that, compare your nums of m with target. If they are matching, return mid value. Else if nums of m, if the middle index value is less than target, if the middle index value is less than target, which means if the middle index value, in this case, what is the middle index value? First case 13. 13 is 13 is less than 19, which means I need to search on the right side. So left L equal to m plus 1. Why I am doing m plus 1? Already m is compared. Already m is compared. That's why. And if not r equal to m minus 1, search on the left side. Search on the left side. Very simple steps, guys. If it is not my current value, if it is not mid, if it is not on the left side or right side, maybe it will be obviously on the left side. That's all. At the end, if we don't get any answer in the above pattern, I'll simply return minus 1. They're asking if the index is not there, return minus 1. That's all. This is what the question is. And this is what the algorithm or code that we have. I hope this is clear to everyone. Initializing the values while left than R, calculating the mid, first step, comparing with the target, second step, if not searching on the right side, or if not searching on the left side. That's all, guys. This is what your binary search algorithm is. I hope this is clear. Thank you.